Yeah, so again, my name is Jurapari. I'm solution architect at AWS, based here in Finland, and going to tell you today how we are helping customers to get insights from OPC UA data. Mika mentioned previously EC2 instance, but how many here know what AWS is? Cool, quite a many. Quick recap on that. So everyone knows Amazon.com, the e-commerce site, and back in 2000s, after a decade of operating the Amazon.com, we noticed that we have actually built quite core competency around building data centers and providing capacity services on Amazon teams to build this highly scalable and resilient e-commerce site. We thought that, hey, this is something that we could provide to our customers. And in 2006, AWS was announced, and we released our first service, Amazon S3, or Simple Storage Service, which allows our customers to store unlimited amount of data with durability of 11 nines. And now, 18 years later, we have over 200 purpose-built services based on our customer requirements, over millions of customers, over 130,000 partners, and Amazon S3 hosts exabytes of data and serve average of 150 million requests per second. How many of you know that we provide IoT services to our customer? Okay, quite a many. Past years, we have innovated a lot in IoT domain, and we have released services like AWS IoT for LoRaWAN, which allows our customers to connect their LoRaWAN devices, and AWS IoT Twin Maker, which allows our customers to build digital twins of their physical assets and link those assets to data in real time. And this year, Gartner recognized us as a global industrial leader in IoT platforms. And we see this recognition, it reflects the breadth and depth of our industrial capabilities that allows our partners and customers to build applications to drive improvements in performance, efficiency, and availability. Let's dive a little bit deeper on how do we actually help our customers to do this. When we discuss with our customers, we see them many times face similar challenges. For example, the connectivity. How do you connect your different vendors on the factory floor, different protocols? How do you connect your machines over the OT/IT network? How do you process data locally once you can ingest that? How do you operate in the situations when the connectivity is not working? How do you get real-time visibility, both operational and business people? How do you do use cases like predictive maintenance without technical expertise or domain knowledge? And of course, finally, once you're able to collect that data in huge scale, how do you actually make sense of that? So let's look a little bit about the architecture. So here we see very common scenario amongst the customers. Let's imagine this is a manufacturing customer which has multiple different devices on the edge and machines using different industrial protocols like OPC UA or Modbus, MQTT, very common nowadays, or any other proprietary or custom protocol. And of course, OPC UA server or Historian. We can use AWS IoT Greengrass, our open source edge runtime, which allows our customers to deploy what we call components, which are basically applications provided by AWS, our partners, and community, and customers, of course, themselves. Here we can see we are deploying an MQTT broker locally from the cloud on the device, and the edge gateway can be any industrial PC or microprocessor-based device. And we can connect our MQTT devices there. The device can act as a broker locally, or you can configure it in the way that you can relay messages to the cloud, to AWS IoT Core. You can also use connectors to, for example, for OPC UA or Modbus, to ingest the data for the device. Now you get the data flowing in on the Greengrass core. How do you actually process and make sense of that data? With Greengrass, you can develop a custom component, which is basically any application you want, and you can consume the data locally from the MQTT brokers or the connectors. You can process that data locally, aggregate it, and make decision what do you want to export to the cloud. Another common use case is to do machine learning at the edge. You can train the model on the cloud. You can package that in the format that is optimized for the edge, deploy it to your devices, and do the inference there locally. As I said, Greengrass is an open source edge runtime that you can deploy on any microprocessor-based device. We support both x86 and ARM-based architectures. We support both Linux and Windows operating systems. And you can deploy basically any application on the edge. It can be shell script, it can be binary file, it can be our Lambda function, our serverless engine, or that customers nowadays use a lot, a container. Okay, we have now data flowing in. How do you actually make sense of that data? We have a service called AWS IoT Sitewise. It's a fully managed service, which allows you, first of all, deploy Sitewise Edge to your Greengrass core device, connect that to an industrial data source like OPC UA server, or you can use our partner data sources, for example, from CloudTrail, which can integrate with the other multiple different industrial protocols. You can start to ingest the data to the cloud or process it locally. And then you can model your assets, let's say in ISA 95 format to the Sitewise. You can do things like data transformation, metrics, and calculations on your models. You can then deploy these models either to the edge or in the cloud, and you can build visualization on top of those assets. We also support use cases like predictive maintenance, and you can also define alarms based on the metrics you are collecting or measurements you are collecting from the edge. So we have deployed Sitewise to the cloud, edge gateway to the edge or the OT side. How about the other use cases? You can use IoT core rule if you are already ingesting data through the IoT core or the different devices, just by defining a simple rule to AWS IoT core. And AWS IoT core is basically a fully managed MQTT broker supporting both versions 3 and 5. And once the messages are coming in, which rule, you can just define that I want to take these messages and act based on that data. And in this case, we are sending it to IoT Sitewise. How about predictive maintenance? We have a service called Amazon Lookout for Equipment, which basically works in the way that once you are ingesting the measurements or DAX, let's say, from your OPC UA server, you have modeled your asset, and you can then just define that these measurements are relevant for this condition. It will use the historical data from Sitewise to train you asset-specific model that you can then use and send the data to Lookout for Equipment to detect the abnormal behavior of the devices. And you can then get alarms from Sitewise, and you can act before your devices or machines break down. I want to give a customer example of this. Toyota in North America, they operated over 200 CNC machines and had average of 40 hours per month downtime. And together with us, they created predictive maintenance solution based on Sitewise and Lookout for Equipment. And they were able to detect the failures before they happened and schedule maintenance windows on weekends and holidays. And they were able to cut that 40 hours down to 20 hours and were able to increase operational availability with 10%. How about that operational visibility? So I mentioned the AWS IoT TwinMaker. Once you have modeled your assets to Sitewise, you can just sync them to AWS IoT TwinMaker, upload your 3D model there, and then link that model to your assets. And you can then host those if you are, for example, user of Grafana in Managed Grafana, or you can also use Managed Grafana plugins to read the data directly from the Sitewise. Sitewise also have the monitor feature, so you can, without writing any line of code, you can just define the graphs of the dashboard you want to expose, and this can be published through the cloud, or it can be deployed to the Edge Gateway. So it can operate on the OT side, and you don't need to send the data to the cloud if you don't want to do so. It will also operate if there's an intermediate connectivity. Great. What about business users? I already mentioned Amazon S3. So from Sitewise, you can automatically export your asset data and metrics to S3. And then you can use tools like Amazon Athena, our serverless query engine, and do SQL queries on your S3 data lake, and use visualization in BI tools like Amazon QuickSight or Microsoft Power BI. Then, in some point of time, if you want to do machine learning use cases, you can use Amazon SageMaker, our machine learning services for data engineers and developers, where they can build, train, and host their own machine learning models. Or for the generative AI use cases, you can use Bedrock, where you can use models from Anthropic, like Claude, or Llama from Meta, just to mention a few. And finally, I want to highlight one of the customers I work very closely with. So Kone, everyone knows we are here in Keilaniemi. So Kone is a global leader in elevator and escalator industry, and they move over 2 billion people per day. And they have built their IoT fleet on top of AWS IoT Core. They have hundreds of thousands of devices sending data, and they can also control those devices. And they have already gained over 70% proactive identification of faults, and also 40% reduction in customer-reported elevator and escalator issues. Great, thank you. So we have a demo there on the booth, both on the TwinMaker and the AWS IoT Sitewise Monitor. If any questions later on, or want to have a deep dive session, any of these technologies I talked today, or just want to share a use case with us, please ping me or send me an email. Thank you.